In this video, we would learn how to solve system of equations using graphing calculators. I would be using TI84 plus. Yeah, right. So the first thing is that we have to feed the values in this calculator, right? So here's graphing calculator. Let's try to feed this value. So press second and then matrix and then add it. Okay, so we are feeding our values here. Add it and then okay, which matrix you want to add it. Say, let's say for example, like say matrix E, for example. Let's give it name E. So E, and you see that it has 3 rows and there are 3 variables and one this last column. So it would have 3 rows and 4 columns. So we press 3 here for rows and then 4 for columns, right? Enter. And now you feed these values. So in the first one, so you have x values here, so that's a coefficient of x, that's a 1, enter, and then coefficient of y 1, enter, coefficient of z 1, enter, and then 9 constant, enter. Then for the second equations, the coefficient of x is 2, enter, negative 3, enter, 4, enter, and then 7, enter. Okay, from the third equation, so coefficient of x is 1, coefficient of y is negative 4, coefficient of z is 3, and then the constant is negative 2. Right, so this is a matrix. We feed it these values, right? So now go second and quit, and then now okay, go back. So second and matrix, and now go to math, and from here you select this RREF, that's okay, B, that's RREF. Press enter, and then here you would bring in your matrix. So in our case we had matrix E here, so again second and then matrix and then matrix E, select it, okay, close the parenthesis and then press enter. In this one you see that these are like decimal numbers, right? So we need fractions here, so we can do it like this way. So math, and you see that as a frac, so press enter, so then press enter again, so the same matrix come in the fractions here, right? So we have this as our matrix, right? And we can see that this is not exactly in the all the diagonals are ones and above below zeros as we need it for Gauss-Jordan form. And you see that 1 actually entire row is 0, so it's indicating that this has infinite many solutions. Okay, and now here we have to rewrite this matrix into system of equations, and then okay, do a little bit manual. Equations would be like say x plus 7/5 of z is equal to 34/5, and from the second one, so that is y plus, actually it's a minus y minus 2/5 of z is equal to 11/5, and from the third, so that's 0 is equal to 0, we don't have to write it. Okay, so now you see that these are like say 2 equations with 3 variables, right? So what we do is that in this case the last variable we assume that, so let's say z is equal to itself z, and then solve this for, right, so for x and this for y. So from here x is equal to 34/5 minus 7/5 of z. So that would be equal to 34 minus 7z over 5. And similarly the second equation, so this gives you y is equal to 11/5 plus 2/5 of z, so which is 11 plus 2z by 5. So therefore our solution would be x value, so that is 34 minus 7z by 5, comma, then y value, that is 11 plus 2z by 5, and then z as z. So this is your solution for all z.